Now let's consider the ozone molecule that has 3 oxygens bonded together. So we draw 3 oxygens. Since they're all the same, it doesn't matter which one's in the middle. And we draw the dots from the electron configurations. And so we start pairing up unpaired electrons. Now, excuse me, in this case, we have an unpaired electron here and here. They don't want to stay unpaired. They want to try to bond with something. So one thing I could do is I could connect dots here and connect dots here. That would give me and if I count the number of electrons in the central carbon atom, I have 8. Oops, left out this lone pair. Oops. So if I count the number of electrons in the central carbon atom, I actually have 10 electrons. I have too many. So I'm going to have to get rid of a pair, bring it down to 8. So what I can do is I can take a pair of electrons and move it out from bonding in the central oxygen atom to an end oxygen atom. So now it's taking one of the bonding pairs. So now what I have is this. So now if I count electrons around each atom has its octet. 8 electrons around it. So to do that, I had to move a bonding pair away from the central oxygen to an end oxygen. However, I could have very well done, instead of to the right oxygen, I could have done it to the left oxygen and ended up like this. So these two structures are the same, because if I just flipped them like a pancake, they would look exactly alike. So they are called resonance structures. I don't know if you can read that or not. I'll write it here. Resonance structures. And the real structure is somewhere between the two resonance structures. This is just a model, so it's not perfectly reality. So the real ozone molecule exists between these two resonance structures, and so instead of one single bond and one double bond, we actually have an average where we have 1.5 bonds to each oxygen atom. The Lewis-Dot theory gives us the resonance structures, and the real structure is in between somewhere.